Example number 1. The car in the figure moves in a straight line such that for a short time its velocity is defined by 3t squared plus 2t, and this is given in feet per second, where t is the seconds. Determine its position, so it's asking us for the position, and the acceleration when the time is equal to 3 seconds. They're also given us some initial conditions, that the position is 0 when the time is 0. Okay, so if you guys remember, we have position, velocity, and acceleration. I can go from position to velocity, from velocity to acceleration if I derivate in terms of the time, and I can go backwards if I integrate in terms of time. So if I have velocity, we're right here. To find the position, I have to go here, so I have to integrate. And then to find acceleration, I have to go here, so I have to derivate. So that's what we're gonna do. Let's start by defining a coordinate system. So we want our origin here. We're gonna follow the drawing. And then we want our positive x in the direction that the car is moving. So we're gonna define the right positive. Let's start with position. So we have velocity, which is a function of the time. And we know that in order to find position with the velocity function, I can integrate in terms of time. So we know that the velocity is this change in position in a time interval. If I solve for the position here, so I have v dt, I move this to this side. And then on the other side, I have ds. So now I can just integrate here and integrate here. So we have what? We have ds between 0 and s. That's the condition that was given to us here. It's equal to now v. I'll just flip this. I move this here and I'm moving that one here. So now I have v, which is 3t squared plus 2t dt between 0 and t. That's the other condition that was given here. If we solve for this, on this side we have s minus 0. This side we have 3t to the third over 3 plus 2t squared over 2 between 0 and t. Or in this case, it will be s between 0 and s. Let's do step by step. So if I solve, then I have s minus 0 equal to, I can cancel this. So on this side, I have t to the third plus t to the second. So I have that s is equal to t to the third plus t to the second. So this is my relationship for position. They're asking us for the position when the time is 3 seconds. So I just plug the time in here. So I have s is equal to 3 to the third plus 3 to the second, which is equal to 36 feet. Now we can do step number 2, which is the acceleration. So if we go here, we have now velocity, and I want to go to acceleration, so I have to take this path, so I have to derivate. So we still have our velocity in terms of the time, And we know that the acceleration is just the change in velocity in a time interval. And we already have that velocity, which was given to us here. 3t squared plus 2t plus 2 squared, no, 2t. Right, so if we derivate this, we have 60 plus 2. So this is the relationship for acceleration. So as you guys notice, the acceleration here depends on the time. So we cannot use the equation for constant acceleration. I'm gonna leave a note here. Or like equations for constant acceleration. Again, because it depends on the time. The acceleration is changing as the time changes. So they're asking us for this specific problem for the acceleration, again, when the time is 3 seconds. So we have A equals 6 times 3 plus 2, which is equal to 20 feet per second squared. I got a positive, which means it's in there to the right. That's the solution.